Okay, good afternoon. I hope you had a good lunch. Difficult moment maybe directly after lunch, but I try to keep you awake for a coming 20 minutes. And I changed my title a bit because I would like to share some thoughts with you about how we should make our food products and food ingredients in future. So that's why the title is now Concepts for More Healthy and Sustainable Food and Food Ingredients. And why is it necessary? I think you've seen a lot of data, but our diet nowadays is produced in a rather inefficient manner. What we notice worldwide is that the more income people get, it's indicated on the graph on the right, the more resources we need to make our diet. For example, in the Western world, we need to produce 7 times the amount of proteins compared to the amount of proteins that we actually consume. And a similar value is true for the energy. So the energy that we need to make our food is about 5 to 6 times higher than the actual calories we consume. And also food industry is rather affluent. It uses 40% of all energy, 10% of all water, and produces 10% of all waste which is produced. Now, what are main causes of inefficiencies? Probably you're aware of that. But what we are doing is we start to consume more and more products from animal origin, and the protein conversion from protein to animal is not very efficient. A big part of it is used as an energy source by the animal. A second cause, and that will be the second part of my presentation, is the use of highly refined ingredients. The fact that we use only specific ingredients, for example starch from a material, leads to low yields on one hand, but also leads to high water and energy consumptions and might have an effect on the health as well. And finally, we produce quite some waste, especially in the Western world. Food has become quite cheap, so why not spoil a bit more? There's not a big price consequence for that. So I think these are 3 main causes. Maybe there are others, but these are quite important causes. And in my research, I focus on 2 aspects of those, the first 2. So I don't focus so much on waste management, but I focus on the first 2. How can we reduce the consumption of products from animal origin? In a way, we could just replace it by plant-based alternatives, just consume less meat. But what we noticed is that consumers are also interested in products that really resemble meat, that have the same structure, but are made from plant materials. So one of my part of my research focused therefore on the production of fibrous materials from plant-based materials. But those products only become more sustainable if the raw materials, if the ingredients for those products are also produced in a sustainable manner, and that's not always the case. So we also should rethink the way how we produce our ingredients. We focus on reduced use of energy, water and chemicals, and I think we should focus more on making the right ingredients for a certain application than ingredients with general applicability. And I come to that, what the consequences are. At least, I think it will lead to a redesign of our food process chain. Here in some countries in Europe, I think also in the United States, quite some developments are going on to make fibrous plant materials that have the capacity to mimic meat and that can replace meat in traditional diets. Most of those technologies are made through extrusion. You see an example over here. Another one is a kind of mixing of a protein source with alginate. While mixing, calcium chloride is added. It leads to a local solidification, leading to droplets of alginate in protein source being dispersed in it. Vigorous mixing elongates those droplets and gives a bit of fiber structure as indicated here. You can redo this experiment in a kitchen mixer yourself if you like. But those processes, they are made on mixing processes actually. It's an extension, it's a kind of development of a mixing process, and making a right structure might require a different process. And that is why we have developed in the past a range of devices, shearing devices as we call them, which are dedicated for making structures. A shearing device looks like this. This is a device with two cones. We have an undercone here, an upper cone. If you close the device, a small slab of material is presented, which is deformed in a way which is similar as the deformation occurring between two plates of which one is moving. Simple shear flow. And if you look at more fundamental studies, physical chemical studies, you see that they use this flow to make all kinds of anisotropic structures. And indeed, we noticed that under certain conditions we are able to make fiber structure with dairy proteins and mixtures of plant-based materials. So to summarize this part, I think that there's a lot of things are going on in this area. And quite some products available on the market, I think, are already of high quality, quite fibrous materials, as you can see on the picture here. The structure resembles meat already, and also taste and etc. is already quite good. In panel tests, people hardly notice the difference between chicken meat and those types of products, for example. But the technology we are developing, with really the focus on structuring, might be even more efficient. Extrusion is just a further development of a mixing process, but if you really take the structuring as starting point, you can even become more energy efficient. So I think the next step could be that we develop dedicated structuring processes. We can use mild conditions, keeping high quality. But what we also noticed, and that makes the bridge to the ingredient production, is that not all ingredients are suitable, not all protein sources are suitable to make fibrous materials. What we noticed is that SPC, soy protein concentrate, is a good one, but also a mixture of soy protein isolate and wheat gluten can lead to fibrous materials. If you use soy protein isolate alone, you're not able to make fibrous structures. So obviously, your process should be suitable, but also your ingredients. And there's a close interaction between ingredient properties and your process. So, to summarize, SPC, the concentrate, the less refined material, might have better structuring property than the more highly refined ingredient, soy protein isolate. And that's an important part, because if you make a process which is defined, if you make a meat alternative based on pure ingredients, what we then noticed was, and this is a exergy analysis, and exergy is a measure of the quality of the energy. What you see a big difference is that for pork meat we need a lot of exergy. And a traditional product, especially in the Netherlands, I think also in Germany, is pea soup. So, another protein source. And what you immediately see is that if you compare pea soup, protein content-wise, or the pork, that you need far less resources to make the vegetable alternative. We know that already. However, pea soup is not very fibrous, so if we would like to make a fibrous structure from peas, they hypothesized a kind of process in which they first purified the ingredients. They also had a quite complex structuring process, and the end of the story was that a meat alternative is not always better with respect to sustainability, environmental impact, than the meat product. So if we would like to make a meat alternative which has really reduced impact on the environment, we should make ingredients in a more sustainable manner on one hand, and we should also have an efficient structuring process. I showed you about the structuring process, now I move on to the ingredient production. Why do we need purification of plant materials? On the right side, you see a table of compositions of various plant materials. And clearly, plant materials contain, in addition to protein and fat, also quite a bit of carbohydrates. And we would like to get rid of those carbohydrates to really mimic the meat composition. Meat composition, normally only protein and fat and water. However, we face a protein purity yield dilemma. Protein always goes at the expense of yield. Typically, this is a graph for soy, for example. If you use all the flour, you have 100% yield. If you use a concentrate with 60% purity then you have a yield of, let's say, 60% of 70%. But in the protein isolate, it's only a yield of 60%. You roughly lose half of your protein when making a protein isolate from soy. And if you know that the protein conversion was an essential factor, I think here is something which can also make a meat alternative quite inefficient. But a protein concentrate gives a higher yield than a protein isolate. And maybe you remember that also a protein concentrate had better structuring potential than a soy protein isolate. So the question immediately arises, why do we always focus on pure ingredients? Pure ingredients, especially the first generation, was focused on one single ingredient with the remaining materials just waste, being discarded as waste, giving all kinds of problems. You can also say, it looks like this. Here is, for example, in a potato, we have some starch with a lot of water. We separate it into pure starch and the rest of the material discarded as waste. And you see potato contains a lot of water, so that's the biggest stream here. Of course, working with ingredients, well-defined ingredients, pure ingredients, has big advantages. Well-defined ingredients, global sourcing and exchangeability, and of course, it's very safe. You know precisely what's in there. Fortunately, there were some developments in ingredient production as well. The second generation, you could say, focused still on a single ingredient, but the waste was treated such that it was less harmful to the environment. And I think the third generation now is that we start to valorize the byproduct stream. For example, there's a company in the Netherlands, Solenic, which also valorizes the proteins from the potatoes as well. But still focus on pure ingredients, still the dilemma of having lower yields than you can have than the potential in the plant materials. So this is how we make our food products. We take a raw material, we separate it more or less into pure constituents, and then combine those pure ingredients into the final desired composition and structure the product. That's clearly not efficient, because it is convenient, well-defined stable ingredient, quality controlled supply, but hardly any food product consists of one single pure ingredient. So why do we need pure ingredients? Can't we live with mixtures? Can't we live with concentrates, for example? And we completely destroy the structure which is present in natural materials and the presence of complex materials. Normally they're discarded. And maybe they have unique properties. And more evidence becomes available that, for example, carbohydrate protein complexes have very good properties for emulsification. Maybe even better than the proteins alone. So the message here is that we should appreciate the natural structure of proteins, natural structure of plant materials, and have less focus on the use of pure ingredients. So this is how I see future processes. We take a raw material that consists of protein and carbohydrates and oil. We take a fraction which is suitable to make your final product immediately. So what you see is that we start to connect the protein, the product and the raw material. And the product dictates what fraction we have to extract from the raw material. And ideally, of course, we find a second product that can make use of the rest of the material. If you take this concept, then I think that we need far less purification steps, milder conditions, etc., etc. Of course, there's a consequence for how we design our process change, because making standardized ingredients in big factories is not possible anymore, but I think we can produce it in a much more efficient manner. Closer look at the meat ingredients for meat alternatives. SPC, 65% protein and about 35% carbohydrates and some water. It can be obtained through removal of oil and soluble ingredients, and it gives rise to fiber structure. Soy protein isolate, more than 90% protein, requires much more extensive purification procedure, harsh conditions, chemicals, etc., and does not give fiber structure in shearing device or an extruder. So the functional properties for structuring are less good than SPC. So here, for this specific application, less purified ingredients have better functional properties for making a meat alternative. If purity becomes less important, we can also induce new separation principles. And I can give you an example for wheat fractionation. Wheat is being fractionated in protein, vital wheat gluten, and starch in a process that uses a lot of water, indicated in this scheme. Here we see the dry material of flour, which is separated into the starch, the dark blue, a protein stream, and the rest stream. And we need water to create mobility to allow the separation of those materials. But eventually we'd like to have dry materials, so we also need a lot of energy for drying. Remarkably, we found that the shearing device I introduced earlier could also lead to separation of wheat flour into enriched fractions of proteins, dark yellow part, and a starch fraction, using less water than you need to bake a bread. And suppose this process can be translated into an industrial process, then the picture looks like this. We need far less water, so we need far less energy to dry. However, the composition from starch and the protein are not completely identical to the composition you get after a washing process indicated above. But is that a problem? Suppose we can have this process in an industrial bakery, and that factory needs some bread improvers. Why not take the middle part? And also the water, what's in the middle part, can be used in the bread dough as well, so I don't need drying. And this starch fraction can go to biscuit dough. So 100% use of material, no drying, if it is able to translate this process and place it in the vicinity of your final application. What we got, by the way, is in this process about 60% protein, 80% vital wheat gluten, to compare, starch with less than 2% protein, while in normal starch, wheat starch is about 0.2, so less pure, but, and we tested over here, much more functional. Protein-wise, we needed far less protein to get an effect on bread improving compared to vital wheat gluten, and we explained it by the fact that the process was milder on one hand, and we did not apply the drying step. So we focus on functionality rather than purity. New processes can become available, and they might become much more efficient with respect to energy use and raw material efficiency. So what we think is that the fourth generation of ingredients should focus on functionality. Functional properties should become important. And that leads to probably what we think dedicated smaller processes which are in the vicinity of the final application. This was about energy use and research use. There's also, that was in the title of my presentation, a health effect. Because our current diet, it was already explained tomorrow, give rise to some health effects, some health problems, all kinds of diseases. In a way, we have the combination of malnutrition on one hand, deficiency of micronutrients, and obesity, excess of energy on the other hand. And there could be a relation to the fact that we use highly refined ingredients. For example, starch as a thickener. Starch as a thickener is highly refined. It is just starch. From a nutritional point of view, you can say it are just empty calories. And suppose if we would make a starch fraction which is less purified, maybe there's some fibers in it, maybe some vitamins or minerals still, maybe it could lead to an increased health effect. It maybe could contribute to making our diet a bit healthier. A similar reasoning can be given for the meat alternatives. I already said that the SPC containing carbohydrate fibers had better structuring potential than SPI. If we have a look at the typical Western diet, what we see is that it's too rich in proteins. We can reduce our protein intake without any problem, but a little bit too little in fiber. So if we can replace meat buy a product containing a bit less protein, but more fibers, maybe it can contribute to a little bit healthier diet. Maybe there might be some health effects, because there are more fibers, less proteins and less animal proteins, and that coincides with the fact that the polysaccharides also have advantages in the structuring process. So also from a health perspective, if we focus more on functionality rather than purity, we can have also some advantages as well. Now, to summarize my whole story, what do I think? Products and processes of the future. I think there's a clear need that we have to make more healthy products, or at least give products that can contribute to a more healthy diet, that are produced in a more sustainable manner. There are positive developments, especially in the meat alternative. I think there are very good products that can replace meat quite easily, and what I think is that we have to develop similar technology to replace egg and egg functionality, dairy product, fish, etc., etc. But also, ingredient production should become more sustainable. And how can we do that? We can do that by having a less focus on purity. It will, however, lead to large changes, of course, in the process change design, and there will be a more increased interaction with your raw material and your final product. But I think there's also a task for us as scientists, namely that we have to do quite some efforts, scientific efforts, to understand the behavior of those more complex materials and cherish, appreciate the structure present in natural raw materials. And with that, I would like to thank you for your attention, thank my co-workers, and thank you very much.
Any question for Dr. Laban there, board? Here.
Sorry, one question. If we are reversing our diet from meat to plant, which is great, sustainable, but how are we going to get the amino acids which are in the
Yeah. So your question is what to do with the micronutrients being present in meat. First of all, I'm looking a bit to the situation in the Western world, and because the products are meant for those consumers initially to replace part of their meat. I would already be really happy if they replace, for example, 1/3 of their meat by those types of products as a first step. Then there is no problem at all. You can do it without any problem. If it goes really to 75-80%, maybe we have to do some fortification of those products. But that's really far in the future, I think.
Any?
one more. It's not relevant to this one, but what about the insect proteins?
Yeah.
Is it going to be something which can be mixed with these?
Now, theoretically, maybe. I always say that what we should do is try to reduce the number of conversions from proteins. And if you, I think it will be very difficult to become more sustainable with insects than, for example, with chicken meat. So therefore, for me, I don't see the clear benefit of changing to insects.
Any other question? Thank you very much, Doctor. Thank you.